Greetings. So, as is traditional at this stage, we're going to give people a couple of minutes to dial in. For those of you who are just dialing into the webinar for perhaps the first time, this is a series where we go through various topics related to open source compliance. Today, we're going to be focusing on two things. One, software heritage, which is a repository with a goal of having all the source code for software recorded in one location. The second talk will be focused on container compliance, a topic we've covered already more than once. Previously, we were really doing a problem statement, triaging what are we going to do about container compliance? What's the problem space? Today, we're moving to the solution part of this discussion. We're going to talk about how the registries in containers can be used for compliance at scale. The discussion on software heritage will be led by Roberto, who is a director leading the initiative. The discussion on containers will be led by Scott Peterson, who is a senior counsel at Red Hat and a long-time highly visible member of the legal side of open source. As always, this webinar is positioned as if it was a radio show where the audience has dialed in. Please do not hesitate to jump in with questions, comments, or suggestions. Our speakers are here to share knowledge in much the same way as we would do at conferences if we still had travel. And as such, they are as welcome to your knowledge as you are presumably to them. The first part of the webinar, I'm going to give to Roberto with Software Heritage. Roberto, would you like to share your screen?
Absolutely, we'll be delighted to do so. Let me do this. Okay, is it working?
Yes, it's perfect.
Okay, should I start?
Please do. Over to you.
Okay, thanks a lot. Well, first of all, let me say I'm very happy and delighted to be here with you today to tell you a little bit more about software heritage. This is an infrastructure that we have been building for some 5 years now that has some revolutionary potential for open source in general. Let me start with a quick introduction about myself. My name is Roberto Di Cosmo. I am an Italian. I'm married to an Argentinian. I live in France, and I'm a computer science professor. So I have to juggle daily with 4 different languages, so please forgive me if my English is not as fluent as I would like it. I have spent 30 years doing research and education, so educating the next generation of software engineers and computer science researchers. 20 years as a software developer and advocate in the open source world. And then as one grows older, wiser, as one would say, I started building and directing structure for the common good. And software heritage is actually, I believe, the most important endeavor I ever started. Let's talk about this. I mean, software heritage is an important new infrastructure in the world of open source, which is relevant to answer several questions that I'm sure you have talked about for a very long time in this community, which is knowing better open source software. Of course, open source is revolutionary. We all know it. I mean, it has changed the way we do software development, we do business with the industry in the IT arena. And one of the key elements is that, of course, by using open source software, you actually reuse an incredible amount of components that are already built and that you can integrate in your application. You have so many different studies that show this. But for example, one which was popular a couple of years ago was done by Sonatype. They looked at all the Java application they know of, and they found that 80 to 90% of each new application is just reuse. So the good news, you no longer need to rebuild everything from scratch. You can just basically assemble many, many different pieces of different colors and shapes to form a puzzle that is the application you want. Now, the big question is, where do you find these pieces? What is their color? What is the shape? And if you look around at what is available today, many people know very well guitar, which is the latest game in town. But an incredible amount of important component of software come from different places. The very old good SourceForge, different archives like CTRAN, CTRAN, CRAN, so many others which are out there. And so the question then comes, okay, this is very positive. I do not need to rewrite everything. But then the question is, where do these pieces come from? I mean, the software I ship, the software I use, the software you acquire. If there is a bug, where does it come from? If there is a vulnerability, how can I track it? I mean, so basically, now you have a principle which is very popular, which is coming. I mean, in the banking area, you know the KYC principle that says you need to know your customer. But in IT, now it is essential to KYSW, know your software, know where it comes from. But if you really want to know where this software comes from, I mean, it has been, I'm sure, at the core of the discussion of this community for more than a decade. There is a growing consensus that you need an open approach to answer this kind of question. And this open approach starts with an open process that everybody need to agree upon, because then you can share information. Then you need open standards to share this information. And so the open process that is most popular is OpenChain. I'm very happy that she invited me to talk about this today. Then you have open standards, and here SPDX is a very popular data interchange standard for package information. Of course, you need open tools, but then in the end, you also need the open data. You need a place where you find all the pieces of software that you have assembled and all the information that allows you to track them and know where they come from. And this brings us to software heritage, which is actually the missing the missing element in this picture. Was a missing element in this picture because now you have it. What is software heritage? Well, software heritage has been started some 5 years ago with a precise mission, which is to go out there, collect the source code of every single line of software ever written. I mean, if we can get hold of them, and it has disappeared, it's too late. And the idea is to collect this, make sure it is not lost, we preserve it for the long term, and we make it easily accessible. It is not only preserving 60 years of software development and innovation in IT, it is also building an infrastructure to track what is happening in development today and help you build better software in the future. To give you a little bit of an intuition, I mean, software heritage is building at the same time a reference catalog of all the software out there, no matter where a piece of software comes from, even if duplicated in many different places, on GitHub or SourceForge or distributed in Debian or on Bitbucket. Then you will find it referenced in software heritage, because this is our mission. But it is not just a catalog, it is also an archive. This means that a piece of software that has been added into the software heritage archive is meant to stay there forever. It is not the same as code hosting platforms like Bitbucket or GitHub and the other, which are extremely powerful tools to develop together, but they do not guarantee that software will stay there. It's just a tool to build it, and a project can be removed, renamed, moved to another place. In software heritage, what comes in stays in. And then by building together all this information, we are actually starting to build a revolutionary infrastructure for exploring everything that happens in the world of source code worldwide. Well, this is, let me say it very clearly, an international non-profit initiative. So we are not the company, we are not the startup, we are here to build an infrastructure to preserve the software commons on the long term. That's the reason why we are building an organization under the umbrella of the UNESCO, United Nations Educational, Scientific and Cultural Organization, with support from many organizations, many of them you will recognize in this. And this is also the reason why we actually are not doing contracting work. We are accepting donation or membership or sponsorship from different organizations. First of all, INRIA, which is a national research Center for Computing and Applied Mathematics in France. It's a public institution. And then so many different sponsors coming from IT companies, from banking, from university, from academia, from different areas, or organizations like the Open Invention Network. And the doors are really open to everybody. And the more people come in, the better the result will be. Behind software editor, there are real people. Here you have a picture taken this summer of the full team. Not everybody is present. We are more or less 14 up to now. But you see, we have a nice logo. We have a spirit of body spirit for building on this. Everybody is extremely motivated. You might recognize Stefano Zacchioli here, who was a Debian project leader for 3 years. He is my number 2 in this organization. And what we are doing is really a common infrastructure for serving the need for cultural heritage, for industry, for research, for education. And we have assembled up to now the largest archive of software support ever. There are over 120 million projects already archived in software heritage. We deduplicate everything, so at the end, it is boils down to 8 billion unique source files and counting, because we are, of course, growing the archive every single day. Why I was saying that this is actually a revolutionary infrastructure, let me give you a couple of hints. First of all, when we get all these software projects from all over the places, maybe duplicated, maybe with parts copied from one place to the other, we put all these software projects with all their history of development into a single gigantic graph, which is fully deduplicated. So if the very same file content is actually present in different directory, different name, each directory is present in different revision and different project, etc. We know it because it is all in the graph. So this is an incredible viewpoint on the software development worldwide. It's not the same as storing each project one by side by the other. It is a long-term archive, so it makes sure you can access all this information forever. But it is not any graph. It is a special graph we are using. It is actually a Merkle graph. And this is a basic technology which is used in all the blockchains, distributed version control system, distributed file system all over the world, which is based on cryptographic identifiers that allow to identify any part of this particular graph here. A file, a directory, a revision, a commit, everything has a different identifier, which are key for building trustable and traceable software bill of materials. These identifiers are already available today for over 20 billion artifacts. Now let me zoom very quickly on a couple of industry use cases where what we are doing is actually already used and interactive. For this, let me give a little overview of what are these cryptographic identifiers. What we are providing are the sort of heritage identifiers or SWID. They look exactly like this one. They are built of a prefix, SWH, which is today registered in IANA, the schema version, because the schema may evolve over time, an object type tag, and objects can be contents, can be directories, revision, releases, or snapshot. And then you have here the cryptographic hash of this particular object. You can add qualifiers that allows you, for example, to pinpoint particular lines or particular origins. But the important point to notice here that this is an emerging standard for identifying component. It is now part of the SPDX 2.2 that was announced recently. As I told you, it is registered with IANA. It is also a Wikidata property. And you can use these identifiers to precisely verify the particular software component is exactly what you want. And you can also resolve them on the software heritage archive. For example, you look here in this slide, I have one of these identifiers with a resolver. If I click on the identifier, what you will see right now is the software heritage archive coming up with exactly the lines of code I wanted to show you, highlighted for you. And this is a particularly funny part of the source code of the Apollo 11 control computer. But I would spend too much time talking about this. It's fascinating for me. So let's move on. Why is this interesting? Because, you know, for example, I have two Windows use cases that use suites. One is to actually satisfy obligation for the distribution of complete and corresponding source code. So you have obligation to distribute the source code or components you embark in your software. And you know that this is kind of a pain in the neck because you need to keep a register and then you need to know where the software is there, maybe offer ship DVDs to somebody or something like this. Well, today is much simpler. You just archive the source code in software heritage and you only distribute the identifier and people get it immediately from the archive. This is a use case that was developed in collaboration with Intel. A second use case is actually to use a software heritage archive as a source of truth with the identifier. You can say, I mean, the components I'm mentioning are these ones. And this is exactly why the Open Invention Network is using the software heritage archive to maintain the Linux system definition. They can just say what exact version of the software they're talking about. And these are just examples. You can think about so many other governance, compliance, security, etc. There are many that are in the making today. So let me conclude. It's very quick, but so I would like to leave time to questions that may arise. If you want to learn more, in the slides that I have already provided to Shane, they will be shared. You will find the full documentation of the suites. You can check with the archive, see how it works. You will see all the news that we post regularly. And if you want to know more about what members can do, what it means to become a sponsor, what the privileges that you get, and the benefits you get, do not hesitate in contacting us here, and I will be more than happy to share information. Okay, so I think I used up my time, and I will stop here for any question that may arise.
If it's okay, I'll jump in with the first question, which is, when it comes to, let's say, automated compliance tooling, is there tooling that hooks into software heritage via APIs or similar? And what I'm really referencing here is, can we use software heritage as an enormous free compliance database?
Thanks, Shane. That's definitely one thing we want to see happen. So the key message we have been trying to convey over the past years is, please don't rebuild another crawler to get source code from all the place just to build a compliance tool. Let's share the effort of building this gigantic archive, and then let's build the tools on top of software heritage. So we are trying to actually provide this. We should just remember again, we are not a company. So we are not selling a product. We are building an infrastructure. And we are very open to do collaboration with companies that want to work like on top of software edge to build this kind of tooling. So we have already a partnership with FOSS-ID. I think they gave a presentation recently in one of these webinars.
They did, and they brought up software heritage too. They seem to be a good supporter, and I think Microsoft as well, right?
And Microsoft is also interested in doing this. But again, remember, we are here working in trying to build infrastructure properly and not to deliver a product right away. So we need support within resources. I mean, what we are doing is huge. And so we do not have timelines to deliver the next open tool immediately, even if you should hold your breath. I mean, there are some demos that were supposed to come into the LLW meeting in Barcelona that was cancelled, due to COVID. So I hope next year we have something better to show you. But definitely, this is what we want to see happen. The tools built on top of this base of knowledge.
Yeah. No, that's a really good point. And I mean, I'm guessing that you're open to collaboration with companies and projects to try to make this happen.
Absolutely. Actually, the best way to work with us is to come on board, become a member, become a sponsor, participate in our annual strategic meeting where we actually fix together the priorities of the next year. So we work basically with a 1-year roadmap, and that we try to align to the needs that come up from the different members that meet together with us. And remember, so we try to build an infrastructure. So we listen to everybody, and then we try to build into software heritage the most generic solution that can satisfy the need of everybody. This is how these identifiers came up. This is how the mechanism for explicitly depositing software and software heritage has been built. This is how mechanisms like Safe Code now have been built. I mean, this all emerged from this kind of annual meeting over the past years.
Alrighty, let's throw open the floor. Does anyone else have any questions they'd like to bring up at this moment? And bear in mind, we're quite lucky to have Roberto on the line, so it's a perfect time to grill him and also seek seek collaboration and engagement.
In terms of software only, how large is your archive at the moment?
So as I told you, we had more or less 120 million origins and 8 billion unique source code files. This includes a different version of the source files. It contains also something which is not software, because we are actually mirroring in particular places like GitHub or Bitbucket, where people are putting things which are not necessarily software. But a rough estimate is 90% of what we have is basically software.
From a physical perspective, how large, like a petabyte or 5?
That's a very interesting question. You know, without the Merkle graph, if we had to store each repository separately, that would be extremely huge. Today, everything in the archive fits in less than half a petabyte, which is remarkable, but this is due to this kind of technology. We have some interesting, if you are interested, I can share pointers to a research paper we have published recently. There is one which was published just a week ago that gives you some analysis, full analysis of the content of the archive, and you will see that, for example, we have observed the amount, maybe this is interesting for everybody, I mean, the amount of new original content that come in. I mean, pieces of software we never saw before. Over the past 20 years, there is a remarkable trend. Basically, the new content double in size every 22 months on average. It's remarkable. Over 20 years has been an exponential like this with very small variations. So we expect the new software coming in to grow more or less in the same way. And so we need to plan the infrastructure to expand accordingly.
Are there some files or repositories that you have not been able to get access to that you really want or you haven't been able to find?
Oh, yes, there are so many. The point is that, you know, there is basically this long tail of software development. So you have huge code hosting platforms where if you spend effort, you can get all of them. Take GitHub, take Bitbucket, for example, and you can get everything which is in there. That's a lot. But then you have many, many, many smaller ones, including SourceForge, for example. But we really want to get the contents of this platform with the full history of development and in an automated way to make sure we can be up to date. So I'm not happy with just a dump. We need to develop adapters for each and every one of these platforms. And then we need to build adapters for each and every one of the different package technologies or version control systems to allow us to embed everything in this gigantic graph and provide you this uniform view of everything that has been built over the last decades. So this requires a community effort. And just last week, we announced that we were awarded a grant from the Sloan Foundation to fund not us, but to fund other external developers, expert developers, which are expert in, let's say, CVS, Subversion, or Maven, for this kind of technology to help build the adapters to get all this information into software heritage. So you see, it's a long perspective, but we really want to build a solid, stable platform, not just get a bunch of data in without knowing how to maintain it. And please, if you know anybody interested in lending a hand, now we have some limited funding coming from this loan sponsorship, which are for people who are interested in contributing. I can share the announcement offline if you want.
All right, we have time for one more question if anyone wants to jump in. Okay, let's wrap it up there. Roberto, thank you so much.
Thanks again for the invitation. Thanks everybody for your time. I will be very happy to listen to Scott's presentation.
And Roberto, we'll be putting this online as a video, and quite a bit of our global audience picks it up. For your reference, we have significant activity in China, Japan, Korea, as well as India. So you can expect quite a few of those parties to have a look at this presentation.
Absolutely, we'll be delighted. And if I need to share some links, should I send them directly to you?
Yeah, absolutely. And I'll highlight them on the video in YouTube when it goes live, and also to our mailing lists and so on. Can I share your slides?
Absolutely, no problem.
Perfect. Thank you very much indeed, Roberto.
Thank you.
Scott, are you good to share the screen, or would you like me to share your presentation? Oh,
why don't you share it? I think it's only a few slides. It's
yeah.
Yeah.
Pull it up now. And I understand that you're kind of looking at a conversational approach here today.
Yes.
I noticed, I got to pause here and just call out something. I noticed that Amada-san is on the line. Amada-san, are you in Japan right now?
Oh, yes, I'm in Japan. Can you hear me?
Yeah. What are you doing? It's 1:30 here.
Yeah.
This is the first time someone else from Japan, apart from me, has joined one of these First Monday calls. So this is new. Okay, back to Scott's presentation. Okay, so Scott, I mean, you've been all over the place in open source, licensing, patents, and so on. You mentioned to me that you've been at Red Hat a couple of years now, and you're having tremendous fun there. And in particular, when we had a call the other day, you mentioned that you're very excited around container compliance because it's an extremely cool area.
It is. So it's an interesting combination of being a cool technology. So what it does is pretty important. And it has technical features which are interesting. And then it presents quite a new legal challenge. So yes, somebody asked me about the GPL in 1992. So I've been concerning myself with the GPL for a long time. And so things that are kind of fresh and new strike me as pretty interesting. So
would you like me to spin up to the first slide?
Yeah, so why don't we do that?
Okay, GPL compliance to containers. How does that work?
Well, so let me start with one point, which is just under container technology, isn't primarily about distribution of software. It's about managing computing primarily in data centers. So it provides a particularly good way to manage complex computing. And as it becomes more broadly deployed, it becomes interesting now to make software available in the format of container images, simply as an efficiency and a convenience in a world where data centers and so forth are managed using this technology. So it's not fundamentally about software distribution, but this is how it. But this is increasingly a new form of distribution, and it's really different from most other software distribution mechanisms, because it distributes, as I assume maybe most people have already heard, a larger collection of software than just a particular application program that might be what is interesting to someone. And so the distribution of a container image is distributing the desired application and other dependencies, sort of the low-level operating system components that are needed to run that application. Many of which, in general, a container image is going to have GPL licensed content. And so the distribution of container images involves the distribution of, among other things, GPL licensed content, which may not be as familiar to some of the people who are distributing container images as might be the case. So this is then the challenge that I looked at was how to make that process of being compliant, and in particular making the source code available, is what I have focused on. How to make that efficient, and do it in a way that is not disruptive and basically gets the compliance challenge out of the way, so that this technology can be used in the way that people want to use it. So let's see.
Should I spin over to the next slide?
Yeah, maybe that's.
Why not? Let's do
All
it.
right.
Okay. So, I mean, when it comes to containers, efficient, productive, and portable, if we're looking at the GPL optics, the first thing that people bring to us when they talk about container compliance is that a lot of people have no idea what's in their container. And it sounds like when you're dealing with a whole ecosystem, let's say a supply chain, which is where we focus a lot, that feels like an almost insurmountable problem when you've got containers flowing through a complex supply chain.
So I think that this is interesting. So much of the supply chain discussion has circulated around, I think, software distribution that's rather different than what is typical in the container world. In the container world, this is a software-only distribution by and large. At least that's not that it couldn't be used in an IoT device or something like that, but that's really not its. The focus of container technology is really a data center technology, and so the supply chain aspects of it are rather different. To a large extent, so I guess the simplest supply chain aspect of it is that there are software suppliers who provide container images that others may build upon. And if those that build upon it distribute it, they should understand what it was that they got, right? Because they're distributing the content that they built upon as well as their own content, right? So this is the essence of container of container images, is that you can accumulate sort of a base and then application that you build on top, and so it is important to understand the origin. You would want, if you're going to redistribute container images, you want to be selective in who supplies your base layers that you're going to build upon, right? So one can reverse engineer things from GitHub, but quite honestly, it might be. Quite honestly, I think the strategy of the future will not be reverse engineering images off GitHub. It will be getting the bases on which you're going to build from sufficiently reliable sources that you can depend on them. And in this particular case, where I'm talking about source code availability, source code for the base should be available, and it should be available in a way that you can easily use it in your own subsequent compliance.
So let's dive into the next slide. I think we're getting close to the point where we see how Red Hat deals with this, and this is the registry native approach. We haven't talked about that yet on container compliance, so we might have quite a lot of interest on how precisely you're doing that.
Yes, yes. So what the terminology here, registry native. So container images are distributed by servers or services known as registries. It's an odd terminology. A registry is a highly overloaded term. It's frustrating, quite honestly, to me. But nonetheless, a registry is the name for a particular kind of server. It's a server that serves container images. And by the way, you should, if you're doing any kind of detailed legal analysis, you need to understand that the thing that you see when you go and you browse around a container catalog is not the registry. You're dealing with a user interface for humans that is a regular website. The thing known as a registry is a separate service that delivers container images. And so what we have set out to do is to have the compliance, the source availability and what you need to accomplish that done through that registry, rather than have some user visible part of the catalog or have some external website that has other information that you have to refer to. Container registries are services that are accessed by tools, and the mechanisms for compliance should take advantage of those existing registry services. And furthermore, if you're going to be in the business of distributing some software in a container format, in container image format, there's an increasing likelihood, I think, that you'll want to host that on more than one registry. And so you want to have a mechanism by which you can accomplish the compliance that you've perhaps put in place in the first registry. You want to, how can you accomplish that if you host at another registry? So the sort of the starting underlying principle here is that the compliance should be accomplished through the registry, not through separate channels. And it turns out that registries are remarkably well suited to this, in the sense that the manner, although they're designed for distributing container images, the manner in which the bits are organized and distributed is quite amenable to distributing other kinds of content. So here, so let me dive in a little bit further into the technical detail, because it is important to appreciate that.
Is this the next slide?
Maybe not quite yet. I don't have a slide really for the structure of how this information is stored. Actually, like software heritage, container registries use a lot of hashes. So anybody who's a fan of hash functions, and if you're not, you should look this up on the internet. Hash functions are one of the most underappreciated tools in computer science, actually, I think. But that's a little editorial sideline. Hashes are central to how Git works and the deduplication that's accomplished there. Anyway, so a container image is a little bit like a web page. There is a thing that you first download, which has a list then of the other components, and you then use that list to go back to the registry and retrieve the components that you want. And so rather than, so this container image actually doesn't exist as a single blob anywhere. It is an abstract thing which has a manifest and then other components which you collect according to what the manifest has described as the content. The reason why this is interesting is a couple things. One is that those content items could be source code artifacts. such as the source RPMs used to build the original base layer, or other kinds of source artifacts, zip files and things like that. And they can be listed in this source manifest and then pulled down separately. The other is, I mentioned, hashes. So hashes are used to achieve deduplication, which is another fascinating topic in itself. And so the delivery of source code, the storage on a registry and delivery is made enormously more efficient than it would otherwise be by storing the source code as the source code blobs for each separate component of software rather than a single blob for the entire container image. And then, as Roberto has mentioned, the software heritage has taken it yet one step further. Their level of deduplication goes down to the file level. So what we have chosen as the sort of level of efficiency for what we're doing right now with source code through a registry is source code is delivered at the level of a source RPM or some other, the unit in which the software is built. So yeah, so maybe that's enough enough detail. If somebody has a question, we can dive into something more at another time. But yeah, so let's maybe take a look at the next slide.
All right, so this is where you are now in practice. And this is really where the I think the excitement is. Does it work?
And so that's right. So until you build something, you don't know what unintended consequences might be, and what things you might break. So far so good. We have actually what we have in production on Red Hat's main container registry is source images. So the term source container is commonly associated, is a term that's often used to refer to the providing of source code through a registry. It's a little bit of a misnomer because it's actually an image, it's not the container. A container has a more specific meaning that's actually not about packages of software. But in any case, we have source images for each of our what are called universal base images. So Red Hat has a kind of offering which are container images that are intended to be the base on which you build, you put other software. And anyway, that offering is called UBI, and I don't know, there's maybe 50 different versions of that. I'm not exactly sure. It's probably a smaller number of versions of images with some detailed sort of subversions within them. But anyway, so there's probably 50 to 100 images in our registry today that have been that have corresponding source images that were not hand built, that were in fact built by our production tooling. So we have production tooling that builds the images that get pushed to our registry. That tooling has been augmented to be able to assemble the corresponding source code into a thing known as a source image, and then push the source image to the registry. And so if you look into a repository, so registries, container, the terminology is terrible. Container registries have these things called repositories, each of which is sort of a namespace. And in the repository for each of these universal base images, you will see images that have tags with names -source on them. So there's a naming convention at present. And you can pull those source images, and you will see that they have, instead of layers that are intended to be the layers of a file system, to create a file system for a container, each layer will be a source artifact. And anyway, so those are in a registry now. We've had them there since about February. We started doing this, and we're getting some experience with that. We are about to begin to push to to push this out to a larger fraction of the images in our registry. And over the coming months, we will hopefully be able to cover most of the registry with this technique and learn about the consequences. And so you don't need any special tool to get these. There's a tool called Scopio, which is a common tool for copying and pushing, pulling, and copying images. Works well on these source images, and you can see what's in them. We don't presently have yet special tools specifically for inspecting and doing stuff with source images, but we do have a tool that's, so the tool that builds these source images, something called the build source image, is a we in fact use it to produce these things. In the long term, that's going to become more like a proof of concept that was an initial implementation, and we'll probably replace it with in the future. But there is a publicly available project called Build Source Image that you can see that takes a set of source artifacts and assembles them into a source image.
So, I mean, when it comes to what you've got in place now, it's a pretty big statement. But I mean, I think you might be the first to get to this stage in containers and be publicly talking about it. And you might indeed have a really interesting way to do this GPL compliance in containers, which, quite frankly, we haven't heard a solution for yet until this talk.
Indeed. So I think people have sought to accomplish this source availability for registry delivered software through mechanisms outside the registry. And these are just crazy complicated or brittle. I mean, they're just being disconnected from the technology that's used to manipulate the software for which you have the corresponding source code. It's just a crazy effort to try to keep all that working. And I think there is no one way of doing it. So different registries may use different approaches to getting comfortable that the corresponding source code is somehow made available. This shows people how you can actually do it using the same basic infrastructure and tooling that's used to distribute the software itself. So in the analogy to existing package management systems is loose. One shouldn't take it too tightly, but if you think of package management systems like RPMs for Red Hat Package Manager, but also Debian has its package management system. And some of these newer, more language-specific package management systems have similar characteristics where they provide a mechanism for building tooling for building and building a package, and they also provide tooling for creating a package of the source code, and you can get the source code through the same kind of mechanisms that you might certainly for RPMs and for Debian packages, you can use the same repositories and mechanisms and so forth. So this takes that same conceptual approach to container images and their distribution to registries, and yeah. So as we move forward and this becomes a more and more widely used mechanism for software distribution, I think this is going to be very attractive. It is such a simplification of the problem compared to other approaches that I think people are going to find this very attractive.
So I'm cognizant we're pretty tight on time, so I'm going to spin off to the next slide where this is the final slide, final primary slide, where you reference a whole bunch of articles.
Right. So the first one. So I don't yet have an article published on the technical details of the images themselves. That is in the works and will be probably in the next month or so. But the first one does talk a little about containers for those who are not familiar with the technology. But then some of the others talk about a higher level sort of the philosophy that I and others in the Red Hat open source legal team, sort of how we think about compliance. So they, they give you a way of thinking about compliance that is what leads us to, to build this particular solution. So there's some assumptions and so forth underlying our way of thinking about it. And you'll see that in some of these. The source actually, the source code is the license. Is given that this is all about delivery of the source code, and we're delivering all the source code. So of course that's not required, right? There's plenty of software in a container image that is under permissive licenses that doesn't require the source code, but we're delivering all the source code. The article, the source code is the license, is interesting to understanding why we think that's valuable, and that relates then to the one below it, an economically efficient model for, this gives you a sense of this is more than just about the GPL. This is about other licenses as well.
Oh, I see we've got Roberto has just raised his hand with a question or comment. Roberto, over to you.
Okay, I just wanted to say thanks, Scott, for this presentation. And I didn't see enough technical details to actually fully understand what we are going and what you're doing here. So are you building new containers that contain the full source code included in them, or are you building companion containers that are actually containing the source code for a given container? I see what I mean. I mean, when you have packages in Debian, for example, you can run apt get source and you get the source, because in the metadata for the binaries, you have those information on the source package and you can get them separately, or are everything embedded in the same object?
When I refer to a source image, we're creating a container image that has no executable code, but in fact has solely source code, and it corresponds to another image with a tagging convention. So having said that, it is, I believe very strongly, we want to take this a level further, because the Open Container Initiative specification for container images has a facility already that conceives how we can think of this in a much better way. So those should be two parts of one logical container image. There's already this concept of different architectures, so you might have an ARM architecture, Intel architecture, a System Z architecture, and you will need different executable containers for those in general. And yet you want those to be logically one, and you want the consumer to pick which one. The source container should be another one of those, like an architecture. And so there is this index, image index, which is already conceived and is already part of the standard that allows you to group those different architectures together. And we want to have this grouped along with those, rather than having to rely on a naming convention.
Absolutely, that's great, because then you can move, actually you can push this logic forward. You can actually think of doing the same when you create a Docker compose, when you run Docker compose.
Yes.
Compose this source code actually together in this way. And then thanks a lot. Now I have a better view of what you're doing. I think it's a brilliant idea. The other point is, what about actually two things. One, about the source of trust. So in some sense, to trust what you are doing, I need to trust the base layer. So you are building the initial binaries and the source code side by side. So I need to trust somebody. So I wonder how you handle this. And then what about rebuildability? Do you think you are going even to that point, or this is out of scope for the moment? I mean, when you have you're rebuilding the binaries.
Exactly. So good point. Let me start at the end. So rebuildability is, as you suggest, out of scope. The source code availability that we have implemented and is presently available now is to be able to rebuild the software components that were then used to build the image. And so there would be some details that so that it doesn't seek to actually fully replicate the building of the image. it's so the ability to take that next step further is interesting. And we've thought about that. As a compliance matter, we're comfortable with rebuilding those components. But nonetheless, we have customer interest in going to the next level, and for other technical reasons, the desirability of maybe make it better. So no, but at the present time, it's rebuilding.
Okay, so I understand. For the moment, it's out of scope, but I mean, this
Yep.
replicability or reproducibility, there,
Yep.
there you have a bridge with the issues you see in open science for the one. If I bring back my professor hat on, I mean, we are extremely interested now in everything related to reproducibility. Or saying
Yes.
and this is really related for rebuilding from source in some way.
Right. This is one step in that direction.
Thanks a lot.
Hi, hi Scott. I have one question about the universal base image license. You mentioned it a little earlier. How does that affect distribution of containers? And yeah, is there any additional obligations? I noticed that it was very heavily documented with Red Hat's name in the license. And do you think this will be something that you want to see more universally used?
So my focus is open source stuff. The end user license, the EULA for UBI, is not my expertise, but I'm familiar with it. So it's I'm not sure about the general usability of it. It might be interesting. I mean, to be clear, the EULA itself is not an open source license for sure. It is intended to sort of facilitate the use model that I was indicating earlier is the reason for UBIs, which is to allow people to, in fact, put stuff on top and to redistribute it.
Does it? Yeah. I guess does it impact redistribution of the container?
So the intent of that license is to permit redistribution. Yes. Not to inhibit it, right? So
it'd be very relevant to anybody doing compliance around a container to somehow make sure they're compliant with this EULA. Even though I understand you're not here to talk about the EULA itself, right, but it does impact anybody who's going to redistribute an open source container.
Certainly, yes.
Okay, great, thanks.
I think we can squeeze in one more question before we hit the hour, if anyone has something pressing. If not, I'll spin over here to the final slide for Scott. Scott, thank you very much for that presentation. I know a lot of our community are going to be super interested in this recording. And speaking of that, before I do anything else, I just noticed that we also have Ninoji-san in Japan on the line. My goodness, what's going on? Everyone is now staying up to 2 a.m. Weird. You know, you put us at home and don't allow us out, and look what happens. Scott, thank you so much. Roberto, thank you so much. And everyone in the audience, great questions. Glad to go through this. Our next webinar will be the third Monday at 5 p.m. Pacific. The speakers will be announced in the next couple of days. Adjacent to this webinar, there's going to be a secondary release, a kind of a condensed webinar beside this with a quick interview of Armin Hemmel on build instructions. And the last thing I want to announce is that Mark, head of our spec work team, is going to be running bi-weekly spec reviews as we look at the next version of the OpenChain spec. Bear in mind that we are just going through ISO with the current version, and we don't plan to iterate soon, but we do plan to start the editing process so that we can capture and collect comments from around the world, particularly once we go out deep into procurement as an ISO standard. Now, Mark is going to be running these bi-weekly calls on the second and fourth Monday of each month. We'll be starting next week. And Mark, I believe next week is going to kick off at 9 a.m. Pacific Monday, and then 2 weeks later will be 5 p.m. Pacific Monday. Is that right?
That's correct, yes.
Perfect. Invites and further details will be going to the mailing list. And beyond that, thank you very much, everyone. If the time zone is appropriate, I look forward to seeing you on the next webinar, if the time zone is not appropriate, I'm looking at you and Madison and Noji-san. I'll see you on the third Monday webinar. Meanwhile, next week, let's talk spec. Thank you all and see you soon.
Thank you, Shane. Thanks, everybody. Bye-bye.
Thank you.
Thanks. Bye.